Okay, and welcome back. So I'm going to show you guys how to add and subtract fractions the easiest and fastest possible way. So let's get started. So the first problem you'll ever see in any textbook is this one. 1/2 plus 1/3. So to add this together, fastest possible way is this. Just put your equal sign, get your fraction bar. Now, take the denominators, okay, and multiply them together. So in this case here, 2 times 3 is 6. And just write it down. The next thing is to multiply this 2 times this 1 here, like this. So that gives you a 2, right? 2 times 1 is 2. And the same thing here. 3 times 1 is 3. Now, what sign are we dealing with? We're dealing with addition. So let's just circle it. So now you add 3 plus 2, and you get 5. That's it, and you're done. Essentially, that's basically it. You should be able to add pretty much anything, right? Any two fractions. Well, let me show you what happens when you have a minus sign. It's going to be the same exact thing. Same problem, okay? I'm going to move this up just a little bit. So 1/2 minus 1/3. Okay, so same thing. Just put your fraction bar, and the two denominators just multiply together to give you 6. And the same thing. 2 times 1 is 2, and 3 times 1 is 3. And the sign we're dealing with is a negative sign. So 3 minus 2 is 1. That's it. Real simple. So that is basically the way to add or subtract simple fractions, okay? So let's do another example. So let's try this. 2/3 plus 1/5. Okay, same thing. Put your equal sign, take the two denominators and multiply them together to give you 15. Then take the 3 times the 1, and that gives you 3. Then the 5 times a 2 to make 10. And the sign you're dealing with is plus. So 10 plus 3 is 13. There you go. I had to do that. Okay, so now let's see what happens when we subtract these two fractions. Again, I'll move this up. So 2/3 minus 1/5. Same thing, fraction bar. Multiply the denominators to get 15. Then multiply the 3 times this 1 to get 3. And then multiply this 5 times a 2 to get 10. And the sign we're dealing with this time is a minus sign. So 10 minus 3 is 7. Simple, right? Okay, so at this point, some of you are probably thinking, wait a minute, hold on a second. I was told about common denominators. Well, I'm glad you asked. So now I'm going to explain to you why this method works. And I'll do it with the first example we did, which is probably the easiest to look at. Okay, so we had 1/2 plus 1/3, right? Let's say you had this 1/2 of a pie here, right? And let's say you had 1/3. I guess I'll try to make that look like 1/3. So if someone asked you, well, how many pieces of pie do you have? Well, you'd say I've got 1/2 and I've got 1/3. But you wouldn't outright say I've got 5/6, right? Without doing some math. So in school, you were taught to make these denominators the same, right? Now, what does that actually mean? Well, that means in the pie pieces that you have, you're actually cutting them up into smaller pieces so that way each one of the pieces matches. Then you could just count them all up and just say, well, I've got so many of these sizes, right? So you've got in here, this 1/2, I've got one of the half sizes, right? Meaning if you have a pie and you cut it in half, this 1/2 symbolizes that you've got one of these halves. This 1/3 right here means that you've got a pie that is cut up into thirds, right? And what that means is that you have one piece. You have 1/3 of this pie. So in this case over here, you've got this piece here. You've got this piece here. You got this piece here. This one here and this one here. I wish I could have done that faster. But anyway, so you've got 1, 2, 3, 4, 5 pieces, right? And so you have 5 of these pieces. Well, how many would you have, like, total? Like, what is the total amount? Well, in this case here, if you were to connect these two pieces together, like take this 1/2 and this 1/3, you'd end up with 6 pieces, basically, total. So you would have 1, 2, 3, 4, 5, 6 pieces, right? And so I'll try to do this really quick. So you have 1, 2, 3, 4, let me see, 5. There you go. So you'd have 5 of the 6 pieces. So therefore, you'd have 5/6, right? Okay, so that kind of takes care of the theory right there. Okay, so now I'm going to show you guys what happens mathematically. So I'm going to use this. I'm not going to erase anything. I'm going to leave it all here so you can see it visually. So I think I should probably move this plus sign over just a little bit. I want to try to keep things right on the screen where they're at so you can see how this all just fits together. So let's take the 2 and convert it to a 6. Well, you would need to multiply it by 3. So let's do that. By the way, this little dot here, this one right here, this means to multiply. You may also see this too, like set of parentheses. Okay, either one means the same thing. I'll talk about that a little later. But for now, let's just use a dot. And the same thing here. We need this 3 to be a 6. So just multiply it by 2/2. Well, that's not so clear. Now it is. Okay? So this 3 times 1, well, that's just a 3. And this 3 times 2, that's just a 6. This didn't finish. There we go. This 2 times 1 is just a 2. And this 2 times 3 is just a 6. Right? And look at this. Here's the plus sign we had. 3 plus 2 is 5. And the denominators, since they're the same, we're only talking about the sizes. Like the denominator just basically tells you, well, what size are you dealing with? Well, I'm dealing with a 1/6 size, like a size that is equal to 1/6. And I have 5 of them. So therefore, I've got 5 of these 1/6 pieces. So of basically means to multiply. So you have 5 times 1/6, which is equal to 5/6. Okay. I'm kind of going overboard here, and the only reason why is because this is the stuff you need to know. Like, this is what makes fractions hard, is the fact that maybe everything that I'm saying here conceptually hasn't really sunk in up to this point. Well, up to the point before you watch the video. Up to that point, let's just put it that way. And so you're watching this because you're trying to get some kind of extra way of looking at the problems that you're working with to be able to solve them quickly and not forget. So you want like a surefire thing that you can use all the time. And this basically is it. Okay. Now, how about subtraction? Same thing. All you're doing is just changing the sign over here. That's basically it, right? So in this case here, if I was to take, well, instead of redoing everything again, we've got 3/6 right here, right? 3/6, and we've got 2/6, right? So if you got 3/6 of a pie, this is, again, we've already done the conversion. So we have 3/6 of a pie minus 2/6, right? So we're taking 2 pieces away from 3. So then you just have 1 of them, right? See, now I think you guys should see the connection between like the math that you do and something physical. Okay, so now comes the interesting stuff. I'm going to show you guys how to do the same type of addition and subtraction with much more complicated numbers, and you don't even have to multiply anything whatsoever, right away at least, okay? And even if you don't know how to multiply, I'll show you what to do with that. So check this out. So let's say you're given something really nasty like this. You have 7/8 plus 9/10. Okay? So 7, 8, 9, 10. 7/8, 9/10. Let's pretend you don't know how to multiply. Of course you guys do, but let's just pretend, okay, that this is a much more complicated problem in a higher level math, okay? This is what you can do. Mechanically, I'm going to show you how to just put this in a form, so that way, I mean, I hate to say this, but if you have a calculator and you have to rely on that, that's totally fine. I get it, okay? You need to get through that test, or you need to be able to get through homework, and you use your calculator as an aid. I'm not saying I don't condone using a calculator at this level, but if you have to use it for whatever reason, I'm just going to pretend that it's like a life and death situation. So just go ahead and use it. You have my blessing on that. But please, guys, just learn your multiplication tables, okay? And I know this stuff is hard, but you know what? You totally got this. Like, this is going to be so simple. By the time you're done with this, you should be able to add and subtract anything. Well, any fractions at least. Okay, so first thing we're going to do is this. We're going to take our fraction bar and write it down. We're going to multiply the 8 and the 10 together. Same thing we did before. But let's say you didn't know it was 80, right? Let's say you didn't know 8 times 10 was 80. You could just do this. 8 times 10. Yes, you can do that. And now you take the 8 and the 9 and multiply that together. But let's just say you didn't know it was 72. Well, you just write 8 times 9. Okay? That didn't come out right. There we go. All right. So now you take the 10 times the 7, and that gives you, well, let's say you didn't know it was 70. Well, just write 7 times 10 like I did right here with the 8 and the 9. So 7 times 10. All right, and the sign you're dealing with here is a plus sign. No problem. So check this out. So you have this over here plus this thing over here. So just write it like that. This plus that. So this plus that. All right. So now you get your handy dandy calculator. I'm going to move this over just a little bit. So you take your calculator and you multiply these things, right? So you've got 7 times 10, which is 70. Well, I guess we'll write the fraction bar first. 7 times 10 is 70, plus 8 times 9, which is 72, and 8 times 10, which is 80, right? And then you add these two top numbers together, and you get 142 over 80, okay? So now what we're going to do is simplify this over here, okay? So here's another little technique that I guess it's good to know. When you're simplifying fractions, now this is a much more complicated problem. The only reason why I'm showing you this problem here is so that way, in case you get a problem that's much more complicated than the first examples that I did, this right here will help you get through pretty much anything that's difficult. Okay, so this 142, you can cut it in half, right? So if that's the case, I could write that 142 as 2 times 71, right? And the 80 on the bottom, I can write that as 2 times 40, right? Yes, there are rules that you can use to break bigger numbers down into smaller ones, but well, we're not going to get into that right now. But anyway, this 2 cancels with this 2, right? And you get 71 over 40. And that's the final answer. So you can go ahead and box that. Now, remember I mentioned about this dot here? Notice how I canceled the 2's right here? I want you to check something out. I'm going to do something on the next screen, right? Let's check this out. Let's take a look at this. You guys are familiar with this, right? 5 times 6. Now I'm going to write this. 5 plus 6. So 5 times 6 versus 5 plus 6. Now at a glance, they could look very similar in the sense that you've got a space in between the 5 and the 6 with some kind of symbol, right? So if my handwriting wasn't, well, if my handwriting was atrocious, let's just say, where I wrote the times symbol kind of like this, and this addition symbol was something like this, then these almost kind of look alike, right? Like this kind of looks like that. And if I was to divide each one by 6, I know you've seen this happen, right? And that's fine. But that's because this is multiplication, right? So I can actually divide by 6, and these would cancel out. However, that does not work here. There is no way you can cancel terms. Here you can cancel factors. This is a factor, only this is just sloppy writing, but as long as I'm keeping track of it, I know that I can do that. So to eliminate all that, I'm going to get rid of all this here. So let's go back to this again. Let me rewrite this again. You see this 5 times 6? I write it this way versus 5 plus 6. Okay? So I'm glad you stuck around this far, because this is not really adding or subtracting fractions. It's kind of like things you need to know when you're doing, like when you're adding and subtracting fractions. So here you can cancel. Now you see why I use this little dot here, right? Because it's different than this over here. This tells you you're able to cancel. So I wish that I could just ask you guys, like, does anybody have any questions, and then just answer them. So unfortunately, I can't do that. But the questions I have been asked, actually, I'm trying to answer most of the questions that you could have asked. But another question would be, well, I've seen my teacher write this, 5 times 6. That's the same thing too, okay? This and this are exactly the same thing. Okay, which means that I can write this as 5 times 6 over 6, and this cancels out. What you're trying to do is you're trying to simplify things down, and because of that, that's the reason why you are taught to find the least common denominator, because you're trying to avoid bigger numbers, right? So this is the last example I'll do, and then on the next video I'll do something with mixed numbers. So let's take a look at 1/6 plus 2/3. Okay, so this is a perfect example where you'd really want to find the least common denominator. Okay, however, using the method that I showed you guys, you would do this. You have the 6 times the 3, right? And that's going to give you 18. Then you have the 6 times the 2, which is 12. And you have the 3 times the 1, which is 3. And you're dealing with a plus sign. So 3 plus 12 is 15, right? Okay, but notice that you get 15/18, right? So that 15/18 can be simplified. This 15 is really 3 times 5, okay? And this 18 is really 3 times 6. So the 3's cancel, and you're left with 5/6. Okay? So this is why you're taught to find the common denominator, or the least common denominator, is because you're trying to avoid bigger numbers. That's fine. You can use the method that I showed you. It'll work every time. It's just that if you can simplify, you should. However, if you don't want to mess with that, you don't want any hassles, this is going to work just fine. Where again, you take this, you take that, you take this over here, and you're done, right? And then sign, obviously. So this method here works all the time. It's just that the more efficient way, I guess, would be if you were to, find a common denominator for both sides. But in this case here, it's just going to be a 6, so you could take the 1/6 plus the 2/3, but the 2/3, what we can do is we can multiply the top and the bottom by 2 over 2, right? And so that gives us 4/6, right? So I'll just write that in white anyway. So you have 4/6. And this is just, 6 is the same denominator, right? So you're dealing with the size of a sixth of a piece, and you have 1 plus 4 of those pieces. So therefore you've got 5/6. See, and the answer is exactly the same. Well, that's pretty much it. I mean, I guess the only thing I could really say would be to make sure you are careful with the negative sign. So if you had a negative here, just be careful with that. In this case here, you can get a negative answer. So I guess if I was to subtract these two numbers here, I end up with a -9, right? Because I'd have 3 minus 12, which is -9. Well, I guess I may as well do that real quick. So let's move this up. And this is the last problem. So 1/6 minus 2/3. So equal sign, fraction bar, 18. 6 times 2 is 12. 3 times 1 is 3. And the sign is negative. So 3 minus 12 is -9. And this is equal to -1/2. So how does that work? Well, this -9 can be written as -3 times 3. That's -9. And on the bottom, well, that's really just 9 times 2, right? However, I'll write it as 2 times 3 times 3, right? You see? So 2 times 9 is 18, essentially. Well, look at this. This 3 times 3 cancels out with the 3 times 3 in the bottom, right? Or I could just say, well, this 3 cancels with that 3. This cancels with that. And you don't just leave the negative on the top by itself with nothing there. It's actually -1. You guys know how to do that. Okay, that's the end of it. I know this was a little longer than you expected, and you learned a little bit more than just adding and subtracting fractions. But I really hope that this inspires you to think about more difficult problems and how you can apply this to those kind of problems. In fact, I guess I could have mentioned it, but I don't want to scare you off. This method essentially is the way that almost every person in higher level math does fractions, more complicated ones, obviously. But that's basically all they're doing is they're just taking these denominators here, right? And just multiplying them together. And then they just do this type of cross multiplication I'm showing you here. It's not really cross multiplication, but it kind of looks like it. But that's basically it. So to get better at this, I suggest just doing a bunch of problems. I showed you a couple here, and I know I didn't do any like improper fractions. I can do that on the next video. It's just, I wanted this one to just kind of be something you could work on, like an intro to it. And on the next video, I'll do some improper fractions and mixed numbers, okay? So that way you get like the whole gist of adding fractions. But if this is all you needed, well, in that case, I guess we're done. So as always, guys, good luck with your homework and tests in the future, and thank you for watching.